Hi, this is David Ferguson with MLC CAD Systems. I'd like to thank the CAD guys for giving their presentation. And what we're going to be doing on the CAM side of things, the Mastercam side, is we're going to be taking some of those flat pattern DXF files they were doing in SolidWorks. We're going to import those into Mastercam 2024, do some source programming with a laser, and then re-nesting those back in, just to give you an idea of how the workflow and the nesting utility works when you really are looking to control quantity. So what I've got in front of me is just Mastercam 2024, and what I'm going to do is I'm just going to go ahead and drag and drop in the first of our DXF files, and I'll just go ahead and do that. And that's it looks like that's the side. So I'll go ahead and call that the side of the part. We'll do some level organization while we're doing this. From here on out, I'm just going to do just a merge, and I'm just going to merge in some more files. So we're going to look for some DXF files here. We'll go for the handle next. And I'll just merge that in. I will bounce it off to a different level here. If I don't do it here, I can always shuffle it around in my level manager. But if I can remember to do that, I'll go ahead and do that. And I'll just offset those by 1. And we'll go ahead and bring that in. And that ends up on level 2. That looks pretty good. Or level 3, I should say. And we'll go ahead and merge in the third and final of our patterns. And that would be the tray itself. Perfect. And again, we'll just offset that by 1. We'll green check. And then I'm going to go ahead and save this as sort of my source file. Now, I didn't get quite the level distribution there, so I should have offset that by 2. But that's okay. I've got an extra level here, and I can simply grab one of those pieces of wireframe and just move it to the level that I want it to be on. There we go. And that would be the handle. And just doing a quick little label here so I can keep track of this. And then I believe that would be the base. Perfect. Okay. Now, I'm going to go ahead and keep these on separate levels, and I'm only going to have one level turned on at any given time. These DXF files are flat to my top XY plane, so that makes programming them relatively straightforward. I don't need to do any sort of translations or moving these around. Just really need to keep the levels organized, so I'm only programming one at a time. And what we're going to do is we're going to go ahead and create a simple contour toolpath for a laser or water jet or plasma style of cut. So I do need to pop over to my toolpaths manager on the left hand side, go up to my machine tab, and I'm going to go ahead and pull in my Mitsubishi laser. We'll let that populate. And again, just basically it's a mill, except it outputs for a laser. So just using the standard milling toolpath, so things like contour is what you'd use here. Now for this, I do want to go ahead and set a specific entry for this toolpath, something I'm going to need to do for all 3 of these before I save them out as source. So in my level manager, I'll make sure that I am on the correct level, and I'm going to go up to my wireframe ribbon. I'm going to go ahead and create a point position. I'll just make sure that I'm making regular points, and I am. Go up to a point position, and then I'm going to hold down my shift key right here about the midpoint of this line while I click. So shift click, which brings up my little dynamic gnomon. I can go ahead and grab that, move it, let's say a 1/4 inch or a 1/2 inch. I'll go a 1/4 inch, positive X, enter, enter, enter. And then that point actually gets placed, relative to where I clicked. Anytime in Mastercam for quite a while, if I need to locate a point or locate an object based on a point or a depth based on a point, if I shift click, I can then use that gnomon to adjust relative to where I'm going. So now that I've got a good sort of entry or burn-in point for my laser, since I don't want to start it right on the edge of the part or that contour, I'm going to pop over back to my toolpaths manager. I'm going to go up to my toolpath ribbon, and I'm simply going to grab just a simple 2D contour. This is a profile, burn, or cut, however you want to call it, and that's kind of really all I need there. So I'll go ahead and start off with a contour, and since I am using an entry point, I'll go ahead and start with a point chain, and I'll go ahead and select that point that I created. Then I'll switch to just a regular closed or looped chain, and I'll go ahead and put a clockwise motion on there. Okay? Now I'll make sure in my lead in, lead out that I'm picking up that entry. If I might have to adjust the start point otherwise, but we'll see what we get. I'll go ahead and say OK. For a tool here, now I do have a very actually special tool for this, And well, I don't have a special tool is what I'm getting at here. So I actually need to kind of create a real simple tool here to sort of mimic the diameter of the laser, or the nozzle of the water jet, or the diameter of the plasma. Just so I get kind of a realistic view and back plot and verify. So I'm just going to right click and just create a very quick tool. This will just be a flat end mill, and believe it or not, the cutting diameter of this tool is going to be 4 thou. And if I zoom in, it is there. There is a 1/4 inch, or sorry, 1/4 inch, a 4 thou, tool that's going to sort of, again, mimic what my laser looks like. I'll just give it a slightly better name. I'll just call it laser. Again, you can, get more specific down the road if you want to, but we'll just call it a 4 thou laser. Okay, perfect. I'm going to go down to my cut parameters next, and I'm just going to set this up as a real basic 2D contour. So computer comp is fine, comping to the left, 2D contour, no stock till even the walls or floors. One thing I can do with a laser is I no longer need to roll the cutter around sharp corners. Not as much a concern. So I'll just go ahead and put that to none. So I'm okay making my good 90-degree corners. No depth cuts, no breakthrough, no multi-passes, certainly no tabs. And I do need to look specifically at my lead in and lead outs. So I'm going to turn off the exit entirely, and I certainly don't need any overlap. And I do want to go ahead and use an entry point. Since I went and chained that, I want to make sure that the toolpath is picking that up. Now, I'm fairly certain that I placed the point there to the right of the midpoint of that line. So I'm going to leave enter and exit at midpoint on closed contours turned on to see if I get a straight across move there. If I don't, if that's not working, I can just kind of adjust the start point relative to that point. So, I'm not moving in in a diagonal motion or an unduly amount of distance. Finally, for linking parameters, for the most part, top of stock and depth can both be at 0 and incremental. That's perfectly fine. Feed plane retract obviously just need to be high enough to essentially make sure that the nozzle or the aperture is going to clear anything on the top of that table. And 200 and 250 thou should be plenty. This material is not terribly thick. So I'm going to go ahead and generate this first toolpath just to, again, kind of see what that's going to look like. I do believe I am seeing, if I zoom in here, yeah, I'm getting a nice straight move from sort of my burn or entry point straight over and then into the contour. And that's kind of what I wanted to see there. I'm not moving to the start of that entity. I'm moving right to the midpoint. So that looks pretty good. Again, I'll do a quick back plot on that. I will turn off my holder just because it's slightly blocking my view. And it might be actually hard to see the tool. But we'll go ahead and we'll step that through back plot really quick just to make sure we're tracking. Again, it uses the graphics will kind of tell you even if you can't see the tool. And that looks pretty good. So very satisfied with that. So we'll exit back plot. I'm not going to post out code or anything specific. What this is going to be is this is going to be a source file. So the actual nesting, when we're determining quantity and all of that kind of stuff, is going to happen in another part file. This one is just to sort of get me going. And the nice thing about using source programming or source file programming is, down the road when I have to do another sheet or another run on these, I have all those source files available, and I'm just basically determining quantity and priority when I determine how many of each I'm going to need. So with that toolpath saved, I'm just going to do a file save as, and I'm just going to go ahead and put this kind of right back where I got it from, and I'm just going to call this, this was an end piece, and I'll just go ahead and tag that as a source, just so I can find it again easy. There we go. And I'll go ahead and hit save. Now, what else I'm going to do is I'm going to leave this toolpath as is, and I'm just going to do some quick rechains rather than rewrite. Again, this part file is all about generating those source files to use later. So I'm going to go to my levels manager, and I'm just going to go ahead and switch over to level number 2. That's my handle. I am seeing the toolpath from the other one still there. Make sure that's my active level. I'll go ahead and go up to my wireframe ribbon. Again, a point position, and I'll just do that quick little shift click since that worked okay. And we'll just go again about a 1/4 inch positive in X. And there we go. There's my burn-in point. Now, since I've got this first toolpath all sorted out, basically, all I really need to do is rechain it. So I can do that a couple of different ways. I can obviously click on the geometry button, and that'll get me to my chain manager, and I can rechain there. If I want, I can go into the parameters for the toolpath, go up to my toolpath type, and click chain geometry there. Either way gets me to the same place. The toolpath will have to regenerate anyway, so whichever way you do it. One has an automatic regeneration, the other one you'll have to click one of the regen buttons. So it just depends on how you like to do that. Probably do the other one, the third one, the other way. So here I'm just going to go ahead and right click and basically just rechain all, dump the originals. And again, sort of second verse, same as the first. We'll start with a chain point for my entry point. Then we'll switch to, again, a clockwise closed chain around the DXF perimeter there. I'll go ahead and green check, and then I'll green check out. And again, I should see, if I kind of look at that real quick in backplot, and I'm just tapping my Sierra key, my S key on my keyboard, and we can see we are moving around that pretty good. A little hard again to see the tool, but it is there. But we can see that. That looks pretty good. All right. So same kind of thing. I like that cut, so I'm going to do a file save as. Again, putting them sort of right back where I got them. Just going to go ahead and make sure I call this one the handle. So again, I can keep them straight down the road because you will forget them. I know I do. So I now have that handle as a source file. Again, switching back to my levels manager, switching now to the base. Again, still seeing the toolpath from the other one, but it's fine. It's just distracting, but it's not hurting nothing to have it there. Make sure I'm looking at just the DXF file for the base, which I am. Again, that is my active level as well. So I'm making sure I'm just putting everything in a place where I can control it. Go up to my point position. Again, shift click at the midpoint here, and again, about 0.25. I suppose I could have used that point I created before, but I do, since it would be in the same place as this one, but I do like to keep associated geometry for toolpaths, separate and, together with their own kind, so to speak, just to make sure I always kind of know what I used for any given toolpath. So for this last one, I'm just going to pop actually not into the parameters, I'm going to pop into the geometry button here. Just a faster way to get to the chain manager. And again, I'll do a quick rechain all. Again, starting with a point and then switching to a closed chain to go clockwise. Green check. Now that toolpath won't regen automatically because I did that outside of the parameters. So I need to click one of my two regen buttons. I'll just click regen selected, and that regenerates that toolpath pretty quickly. Again, I'll check that very quickly in backplot just to make sure I'm happy with the toolpath. Again, just tapping my Sierra key, and you can see here we are moving around that. Hopefully that shows up on the screen, and that looks pretty good. So again, happy with it. All three very consistent toolpaths, basically the same three, or the same toolpath, just rechained for three different basic outlines. So this one, we'll go ahead and do a file save as. Again, and this one I will change the name a little bit to base, again, just so I can keep them straight. And at this point, what I then may choose to do is just go ahead and do one more file save as, and just save this sort of as the project master, toolbox master, master source, something, so I know that this is kind of where everything originally sort of came from. I should probably spell that right, though. Try to spell correctly, guys. All right, perfect. So now that I've got that done, basically I'm sort of done creating those source files. So I'm just going to switch over to a blank and empty session of Mastercam. I'm going to go ahead and load up my laser, my machine. So there's my Mitsubishi laser. Okay, I'm not going into the machine group properties yet. I'm not, selecting any tools or anything. This is going to be set up purely as a nesting operation. So once I've got a machine loaded in, I now have my toolpath nesting function available for mill. Yeah, again, even though this is a laser, it's still the mill module we're doing this in. So I'm going to go ahead and click on my nesting button here. And the first thing it's going to ask me is, of course, is just to define the basic sheet And we'll just do 96 by 48 because that's just sort of the standard, and that's fine. But again, you can have all kinds of preloaded sheets in here that you need. Grain direction, I can choose to ignore or have horizontal and vertical. So it just depends if this is wood, if this is metal that is, grain dependent, and you want to stick with the grain lines up a certain way in the sheet, you can have that. So I'm just going to leave that at ignore for right now. Nesting corner, in this case, will be the lower left, but again, I can set that to sort of any of the square corners of my sheet, just depends on where I'm touching off. Most large tables or gantry machines, it's lower left, that's pretty common. Multiple corners, in this case, off. A fill direction. Sheet to sheet distance, if I've got multiple sheets, is there a space between those sheets that I need to take into account? And of course, a sheet margin. So how close to the edge of the sheet am I going to allow the nesting to work? And we're going to go ahead and just put that at 2 inches, just to put a big number in there so we can clearly see that being applied, right? So again, this is just about basically, defining what my sheet's going to be. Then I'm going to switch to the second tab, which is my parts tab. And this is when I can start pulling in parts. Now, if I'm doing this inside a program, again, where I've already got toolpaths, and you can do it that way, and that's fine. I'd have operations listed here I could select. But since, again, I'm doing this in sort of a blank and fresh session of Mastercam, I don't have that. So I'm going to go find those, and I'm going to right-click in that field, and here's where I can go ahead and get into adding operations from outside files or folders. And this is the whole point of us making those source operations. So operations from files, operational clusters, which we'll talk about in our second half, and operational clusters or files just from an entire folder. So you can just grab everything from a folder. Now I'm going to kind of do this one at a time because I've got more than just those source files in that folder. So I'm just going to do operations from files. And then I just need to go ahead and remember sort of where I parked those, as I like to sometimes joke where I parked my car. And yeah, we'll get to them. I'm sure I've got them somewhere. There we go. And there are those 3 source files I created, plus of course the one that has all the elements in there. Although I guess technically all 3 of them do. So I'll go ahead and start with the base. Okay. And then again, add operations from files. Just say FYI. I can bring in more than one at a time. So this time I'll grab the end and the handle now that I kind of know where they're coming from. And again, those all 3 can come in. So you can just sit there and control click or shift click and just pick kind of whatever source files you want. Now, what we're looking at here are those 3 distinct contours, written for that laser or written with that laser. And when I've got one selected, it shows me what that operation is. And then down below, I can go ahead and dictate a minimum quantity, a filler quantity, an angle I want that sort of held at if I need to. To the right, I can determine grain direction for each individual part while it's highlighted. And of course, just a basic part-to-part distance. I'm going to increase my basic part-to-part distance just so we can see it up to, let's say, 0.5, just to give myself a little bit more space. And for the base, we're going to pretend that Marcus has asked us to make 20? Let's call it 10 toolboxes. 20 is probably too many. So we're going to need 10 of the base. So I'll go ahead and put 10 in there. Okay. For the end, obviously, there's 2 per box. So I'm going to need 20 of those. And again, grain direction I can kind of set while I'm there. Part-to-part distance, that carries over. And for the handle, I'm going to go ahead and set the grain direction just to show that it's working. We're going to make all the handles horizontal. Actually, let's make all the handles vertical. That they might fit better. Just to see if they do show up as vertical, sort of laid out vertically. And again, for those, we're going to need 10 of those. So once I've got some basic quantities determined, I'm going to go ahead and hit my green check here to kind of see what that initial nest looks like. And you can see I made a little bit of a mistake here. I told that one part that the grain had to be vertical, but I forgot to say that the sheet actually had a grain direction. So we'll put that to vertical as well. Okay. And then we'll kind of see what that looks like. Now, actually, yeah, we'll see what we get. We might have to fiddle that, but let's see what we get. There we go. Now that put everything on 2 sheets, so I didn't get quite the yield I was looking for. So a few too many. So I'm going to say, hey, Marcus, we can't get quite so many out of there. So can we make 5 of those? Or Marcus says, hey, we've only got 1 sheet, so I guess we're just going to make 5. The point being, I'm not married to this. This is just sort of my first attempt here. So I can redo my nesting if I'm not satisfied. And basically, the thing is, hey, Marcus, it's not working so great. I also noticed that our handles were not pointing up. So I'm going to put that to horizontal and still my handles to vertical. And we'll kind of see what that does. So you just kind of fiddle around a little bit to get what you're looking for. So we'll go for 5 of those. Now we'll go for 10 of those. Probably should have realized that wouldn't fit, but that's okay. We're just kind of going through the process here to show you, that even when you get down there, you're not done. And now we are getting those handles to go ahead and lay out vertically. So we do have some control over that. And that looks pretty good. I'm pretty satisfied with this. Now, I can't remember for the life of me how thick this material was supposed to be. I think Marcus probably remembers, but I think it was about 30 thou or so. So if I do want to take a look at this and verify, and again, I'm pretty happy with that. And again, I can save this as, again, its own unique part file. And we'll just call this nest test for starters. Although I think I already have one. We'll call this nest test 2 for starters, just so I have it saved. If I do want to look at this in verify, I can go in and use sort of that laid out sheet as some stock. So we'll do that real quick and see if we're kind of happy with this. So again, I'm going to pop into my stock setup. And I'll go ahead and just use a basic make from 2 points. And we'll go ahead and grab 1 corner there and then 1 corner there. And that gets me my 48 by 96. And then I'll just go ahead and put a little thickness in it. I'm at the top. Actually, we want to be at the bottom for that, so it's poking up. So the 0 is at the bottom. And we'll just go ahead and put 30 thou. Again, I think that's the thickness. Marcus will probably correct me if I got that wrong. So with that done, I'll just pop open verify. And we'll just go ahead and take a look at those cuts. Again, it's a very thin tool, so I'm not sure how much we're going to see. I do get a little error there with my collision tolerance because the tool is smaller than my collision tolerance. So that's fine. That's nothing to worry about. And we can go ahead and kind of take a look at that cut. And again, it's kind of small, so there's not a whole lot to see, but it did do a nice job of popping those guys through. And yeah, I'm pretty happy with that. All right, guys. So that's the first half of our presentation, talking about nesting. Again, kind of a traditional nesting approach there. Real thin sheet, high yield. Definitely something in the, if this was on a router, even though we're doing it on laser, if this was a router or a water jet, these are things that, can be expected that we're going to be asked to do. And again, the nice thing about doing it this way is at any point I can do this over. I can go back into my nesting parameters at any point. I can play with the quantity. I can play with, the sheet to sheet distance. I can add more parts if they say, hey, we got some other stuff we want to throw on the sheet since we've got some leftover room. This is kind of, you can evolve this, you're not sort of married to the, the initial programming, so to speak. This is all here for you. And very repeatable very quickly. And again, the ability it gives you to kind of do this again and again with different quantities, different parts. It's just a really, really nice way for that to all work. Okay, so for our second example, the CAD guys got to use a part that they kind of grew up with, that toolbox. And I thought, well, I want to use a part that I kind of grew up with. One of the early parts I was ever asked to program from somebody. And those of you that can guess where this thing came from, you get some extra bonus points. I'll tell you in a sec, though. So this is a solid model of a Subaru EZ30 intake manifold flange that someone asked me to CAD up and then mill out many, many years ago. I think I've still got one floating around somewhere. And basically, they asked me to sort of, here's a piece of aluminum. Here's the part. Can you get as many of these out of it as you can? And at the time, I really didn't know things about toolpath transform. Certainly didn't know really anything about nesting. I had to do a lot of that manually. And it ended up being, not a chore, but, I was kind of felt like I was doing it the hard way. So what we're going to do here is we're going to talk about nesting as sort of a milling application rather than just really a router application. Because one of the things I can do with nesting, and this is sort of similar to toolpath transform, but again with Mastercam we always like to look at different ways to solve the same questions or problems, is nesting allows me to nest what are called clusters, which means I can do more than just contours. I can do more than just the occasional hole. I can group and link toolpaths together and kind of try to do them across an area and get the biggest yield and, again, try to do as efficiently as I possibly can. So what we're going to do is we're just going to set this guy up for a couple of quick milling toolpaths. We'll do a quick contour around the outside with some tabs. We'll do the 3 pockets and we'll go ahead and we'll knock some holes through it as quickly as we can. When we do the pockets, we'll take a side journey a little bit to talk a little bit about arc filtering, and then we'll just see if we can nest all those clusters together on a big sheet, just kind of for fun. But remember, the sheet can be as big as you need it or as small as you need it. So your sheet can be sort of your stock when we get to it. The first problem we're going to run into with this, obviously, is the part is not aligned to anything. It is just sort of off in dead space or airplane space, and that's pretty typical. So I'm going to do a quick alignment. I'm going to go to my level manager. I'm going to pop open a new active level, and then I'm just going to go up to my wireframe ribbon, and I'm going to throw a bounding box around this. Not to define the material or do anything like that, but just to help me align it a little bit quicker. I don't have a lot of sharp corners or square corners to work with. And a bounding box is a really great sort of just simple alignment tool. So I'm going to go ahead and fire off a bounding box, and I'll go ahead and select the part I want to throw the box around, and I'll hit end selection. Of course, at that point, the part is, still off in space, so the box is, I don't know, my boss would be too happy with that as far as an efficient use. But on the left-hand side of my bounding box utility, I do have an auto function, or if that doesn't work, I've also got a manual and a solid face alignment tool. But I find the auto function works pretty well. If I just click the auto function, it's going to go ahead and kind of look at the solid or look at my selection and try to line the box up as best it can. And that did a really simply good job. So I'm going to go ahead and create this as lines and arcs. Again, this box is going to be just for alignment purposes, and there we go. I'm just going to want to get this into my basic top plane just so my programming can be a little bit more consistent than if I was, wherever I am right now. So I'm going to go ahead and jump up to my toolpath transform. My entity transform, my transform ribbon. I'm going to grab a dynamic transform over there, give that a left click, go ahead and Windows select everything. Go ahead and hit end selection up there at the top. While my gnomon is sort of off in space, I'm going to give it just a left click to park it. And of course, if I pick it up and move it, the box, and the selected entities go for a ride. And I don't want to do that. I want to align the gnomon to this box first. Down and to the left of the gnomon always is sort of the secret gnomon button. That is the align or move mode button. When you see the little cube and the sphere, that's in move mode. So again, when I pick it up and move it, whatever selected goes along for the ride. I click that button. I see the little gnomon there. That puts it in alignment mode. That means I can move the gnomon around and my part doesn't move. So I'm then going to click between the X and the Y arrow. That's the only one of those that lights up, and that's actually a button, and that's the button that allows me to sort of locate Z by finding a flat place or solid face or surface to sort of line up and sort of park X and Y. So I'm just going to bring it up onto that top of my part. You can see X and Y are flat or planular to that, and Z is pointing straight up. So I'll give a left click to sort of lock that in. And as I move that around, that's there. So then I'll just bring this kind of up to one of the corners. I'm just going to go to this bottom left corner here, since that's kind of where I want to align it anyway. And I'll go ahead and align either X or X or Y, in this case Y, to my bounding box itself. And if I've already got Z aligned and I've just aligned Y, then X by default is also aligned, because 2 out of 3 is all I need. So at this point, I'm just going to go ahead and hit the move button again. And then I'm going to use some of the sort of the quick buttons over here. I call them the cheat buttons, but they really work great. Basically, these are quick origin or just quick translate buttons. So origin to world, which would be top, basically move to origin, and then axes to world, go ahead and align the part to my top plane. So if I come down here, click on my top plane on my G cube, which you can do these days, I can see the part is pretty much squared up to, whatever plane I choose, either C plane, T plane, WCS, or just world, which tends to always be top. So that looks great. So I'm going to go ahead and green check. I'll go ahead and clear out my colors, and then that part is kind of exactly where I need it to be. So I'm going to pop on the left-hand side, and I'm going to go up to my toolpath manager on the left. I'm going to go up to my toolpath ribbon up top. Well, actually, technically my machine ribbon, because I do need to load in a mill. And I am just going to grab Mastercam's placeholder mill, just their standard default mill. Again, whatever mill you're going to be programming these on, that's what you're going to use. Okay. All right, now for this, I'm going to go ahead and start with the 3 pockets, and for that, I'm just going to pop up to my again toolpath manager, toolpath ribbon up top. I'm going to go to my 2D gallery, and I'm going to grab a 2D high-speed dynamic mill. It's one of my favorite material removal toolpaths, and hopefully it's one you guys use as well. I'm going to go ahead and go to my machining regions here, and I'm just going to go ahead and do solids, because I only have the bounding box, and that's not for machining. And I'll just do some loops, and I'll just go ahead and chain on the bottom of those 3 pockets for those 3 loops. Again, direction doesn't matter, although I do tend to usually do them in the same direction, even though they don't. Quick preview chains, that looks fine, and we'll say OK and get into the actual toolpath itself. Now, I'm just going to go ahead and grab for a tool, just kind of a generic tool. I'm just going to grab a 1/2 inch flat end mill, probably a little sort of medium size for this, but that's what I want to use. I'm going to go down to my cut parameters here. Again, I got my step over, my stock to leave. They've told us that this thing is going to get shot peened and tumbled and powder coated, so nobody cares about the finish. So I'm going to zero out my stocks, so no stock to leave on the wall or floor. Step over distance, I'll drop down to a sort of a reasonable 15% for this. Shouldn't need any corner pre-treatment depth cuts. Breakthrough if you want it, sure. Maybe a little bit of breakthrough just to get through the bottom there. Again, it depends on how you want to program it. Linking parameters, incremental and 0 for depth, since I chained on the bottom. That's where my depth is going to be. Top of stock, I will set to the top of the material or top of the part. That's 0.375. That's how thick our part is. No additional thickness to it. And then I'll just go ahead and make my feed plane and retract 0.2, 0.25 incremental, so they're 0.2, 0.25 above wherever my top of stock is. Now, the other thing that we're going to look at, and I had to go turn mine off before I showed it to you, because mine's always on by default, and we'll talk about that in a second. So that's a pretty good looking little dynamic mill. I do need to get a bit of an entry motion, so we'll do a profile entry. It's my favorite. And Z clearance will go, again, maybe about 20 thou or so. Don't need to go crazy with that. We'll go ahead and we'll green check that. And again, I generate what looks like a pretty decent looking, 2D high-speed dynamic for each 3 of those pockets. Now, if I look at that in a couple of different ways, and I'm going to look at it in backplot, and I'm going to go ahead and kind of zoom in. In backplot, I'll leave my tool off for a second so we can see the whole of the entirety of the toolpath. Leave my tool off for a second. Leave rapids turned on. I am in trace mode up here, so I don't have to press play in backplot to see the whole toolpath. But I'm going to turn on this button here. These are my endpoints or my node points. And what I'm going to notice is that this toolpath is linearized. It's doing most of this motion with linearization. Now we've got an entire video on this part just about arc filtering. I highly encourage you to check that out. To give you the basics, without using the arc filter here, essentially this, dynamic toolpath, so OptiRough, dynamic mill, dynamic peel mill, if you know about that one, they can be linearized. They tend to be very code heavy, 886K, raw toolpath data, and just not very pleasant to run. So what we're going to do is we're going to apply sort of my basic arc filter settings to this. And again, we've got a whole video kind of about talking about how all these work. Highly encourage you to check that out. But to give you the short story about it, I'm going to go ahead and turn on the arc filter. I'm going to allow arcs, and I'm just unchecking some stuff so I can check it again for you. I'm going to allow arcs in all three planes if my machine is happy using a G17, a G18, and a G19. So I'll check those three. Also go ahead and check any entry or exit motion to make sure any 3D arc is not linearized. And then I'm going to go ahead and take my 1 thou of total tolerance for that toolpath, and I'm going to sort of distribute that or bias it more towards arc output than linear output. And my settings tend to be somewhere between 20 or 30% of my cut tolerance for linear motion, that's usually in the tight stuff, and then the remainder for arc output. Now, we're about 886K on this. I'm going to go ahead and green check, regenerate that. The toolpath is now about 106K. And if I look at that again in backplot, you can see I've gotten rid of most of that linearization. That is a much smaller, happier toolpath that will take less time to get on my machine. Machine should be happier running that. And again, I'm covering the same distance, covering the same basic area. I'm doing it with less code, and I'm doing it with more arc output. So everyone should hopefully win with that. If you're not arc filtering your dynamic or your tricordial toolpaths, you really do need to, just to make them manageable in truth. All right, so that looks pretty good. I'm pretty happy with that. I am next going to go ahead and drill the holes. I'm going to use the new sort of selection technique. Now, I think the holes are a little weird size-wise, so we'll just get a tool that's kind of close. Again, this is more about process than anything else. So I'm going to go ahead and pop up to, again, my toolpath ribbon up top. I'm going to expand, grab a drilling op, one of the two. They're identical, so just one of them. And then I'm going to go ahead and use a feature selection. And specifically, I'm going to use a control click to go ahead and click on the inside wall of that first hole, and or one of the holes. And Mastercam is going to go ahead with a control click, go ahead and locate the other matching diameters on that. I'm also plotting out the top and bottom of each hole based on that selection if I choose to use incremental values. And we've got a diameter 0.3543. Again, we'll find something close to that. I think these might have been metric. Who knows? The other issue I have is the sorting issue here is not so great. When you do a group selection like that, sometimes you end up with some odd duck distribution. So we'll just do a quick resort. I'm a massive fan of point-to-point sort. That's usually your fastest option. With point-to-point sort, I am prompted to select a start point. So you just kind of pick your first hole, and then it basically comes up with hopefully the shortest conceivable distance of doing multiple holes. If you got quite a few holes, point-to-point's usually your best bet for that. So that looks pretty good. So we'll say okay. All right, I'm going to pop into my tool manager or my tool page here. I'm going to go find, and I've already forgotten the size of that hole, 0.3543, okay. So we'll find something close to that, 0.3543. How about we go 0.358? We'll go with the T-drill. That's pretty close. We can Scotch-Brite it to get it up to tolerance. There we go. It'll be fine. Always a little slop in those anyway, right, guys? So yeah, T-drill, that should be fine for us. I'm going to go to my cut parameters. Again, basically just choose my drill cycle based on what I'm trying to do here. We'll just do this as a basic drill counterbore. Again, nothing magic to here. Tool axis control, 3-axis output. Linking parameters. Again, new for 2024. If you haven't seen this yet, this is pretty cool. If I'm using either lines, axis lines, or I'm using the walls, what they call a feature or a face selection for these, and I use incremental values, depth, incremental in 0 is the bottom of the hole, incremental in 0 for top of stock is the top of the hole, and then if I want to, retract, clearance can also be incremental, and those will show up there. You do have these sort of color-keyed tabs out on your screen. So, for example, say, they are for each sort of individual hole feature. These are interactive, so I can actually move. So if I want to grab my retract and drop it down to 0.25, that'll do it for all of the holes relative. Very cool. We'll add a little bit of tip comp and a little bit of breakthrough there just to calculate. And that looks pretty good. So I'm going to go ahead and green check that. And that looks like we're getting that tool or that drill, and I should probably turn the drill back on to the bottom of that hole. There we go. And just that little bit of breakthrough. So controlling the depth very easily with that. All right. So my next thing I'm going to go ahead and do is create a new level. I'm going to do a little bit of profile machining with some tabs. So I'm going to call this profile with tabs. Now I have to use wireframe for this if I'm tabbing. Solid chains don't quite work yet for this. So what I'm going to go ahead and do is on that level, I'm going to roll the part over on my screen. I'm going to go up to my wireframe ribbon. I'm going to grab curve all edges. I'm going to click on that back face. And then over on the left, I'm going to ask it to simply do the outside perimeter. Sort of like a silhouette boundary, but maybe a little cleaner. Does a pretty good job. And then we end up, again, with a profile of the part. Lots of different ways to do that. Silhouette boundary also works pretty good, but that works for me. And then I'm going to go up to, again, my wireframe ribbon, and I'm going to grab a point position. But before I do that, in my point style, so I'm going to right-click in my graphics window, get to my attributes bar. I'm going to change this to a square point style. Square points, and just to kind of place one, that's a square point, if you can see that. Square points are what I use for manual tabs. So if I lay square tabs or square points along this part on this wireframe for contour toolpath, that can trigger a tab. The best way to do that once you're making square points, and we'll just go ahead and we'll make them we'll make them a different color. We'll go ahead and make them red, just so they pop a little bit. I'm not sure you're gonna see that. Is to go ahead and use something called Point Dynamic. Point Dynamic allows me to select an entity and then basically move my cursor along that entity. And when I want to, I can left click and I can place a point there wherever I want to. And then I just simply kind of blue check and go to my next entity. Now I'm putting these all in the midpoint, so technically I could have done that manually, but it does allow you to sort of place your points anywhere along that. And one of the reasons why you want to use Point Dynamic is that's one way to ensure that that point, wherever it is along that entity, is actually sort of intersecting or connected to that. They do need to be sort of on the line, right? So now that I've got that, I'm going to go over to my toolpath manager on the left. I'm going to go up to my toolpath ribbon up top, and I'm going to grab a simple contour. We're going to go ahead and go in a clockwise manner here, and I'm going to go ahead and start this, say, out on this sort of rad there. Yeah, so that should be a clockwise cut. We're going to go to a slightly smaller tool. I think that 1/2 inch end mill might be a little large for that. So we're going to go down to an 1/8 inch. Again, just so we can get in there a little bit more. Your experience may vary. We'll see how it goes. Again, we're just trying to show you how to set up a basic tab run for a contour. So we'll just use that tool for fun. I'm going to go to my cut parameters. Again, nothing I really need to do here, although I do got to watch that some of the stuff I had from my previous operation, even though that was in a different part file, I got to watch for some of that. So computer's fine, left is good, tip, roll around sharp corners, that's fine, no stock to leave on wall. Depth cuts, not so much. Lead in, lead out, that's all kind of back to normal. Enter and exit at the midpoint, that'd be right about there, that's fine. Just a little large. So what we'll go ahead and we'll do is we'll just kind of shorten that up a little bit. And I'm just going to kind of make these a little generic. Just say a 20/20 with a 60. Maybe a little bit of overlap. Nothing remarkable going on there. No breakthrough unless I want it. Again, multipasses if I want it, but tabs is what I am looking for. So I'm going to go to tabs. I'm going to turn that on. I'm going to go ahead and set this up for manual tabs to use my midpoint, and I'm going to use square positions or square points for tab positions. Partial tabs, tab width, ramp angle, tab thickness, kind of whatever you need for that. I'm going to put my tab width at 0.5, 1/2 inch, ramp angle 45 degrees. Again, tab thickness 20 thou, that'd be plenty thick. Linking parameters, again, my depth is going to be incremental in 0. Top of stock we know is a positive 0.375 from our last one. Again, feed plane retract, somewhere around there, the same. Then I'll go ahead and I'll hit a green check. Okay. Now, if I kind of zoom in and take a look, I can see I can see those tabs there. You can see the tool's actually lifting up. If that, you can see that the tool is actually lifting up where those red points are, or where those square points are. So our tool is going to come in, and again, I think I use kind of a small tool, and we can see those tab points right there. So when I get to there, I'm going to kind of hop up ever so slightly, move over, and then move back down. So that's my tab. If I were to go back and manually sort of move those points back and forth, the tabs would go with them. So I've got three tool paths here, right? I've got three different tools, three different tool paths. Important to understand these all need to happen in the same position relative to each other. I don't want to kind of sort of split those apart. This is a single part. So I'm going to go ahead and save this out, and I'm just going to hit this. Basically, again, I might tag it as source or something so I know where it is. But those tool paths are now saved. Okay. So what I'm going to do real quick, let me just check something on my bounding box. So those are just a little over 12 inches thick. Okay, I'm just trying to think. I think we're going to do it on a full-size sheet because it's fun. But again, I might want to size my stock a little more realistically. Although, just to show you kind of what's capable or what's possible, we're going to do it on a giant sheet just for giggles. All right, so I've hit saved on this. That's now saved out as a source file. I'm going to go ahead and start again with a fresh one. So just a fresh open session in Mastercam. I will go to, again, my machine tab. I will pull in the same machine. Again, just that placeholder default mill. But having a machine there allows me to go ahead and fire off my nesting utility, which I will now do. Again, we're going to do this on just a large sheet because it's funny. We'll say grain direction is horizontal, so moving that way, lower left. I'll go to parts, and I'm going to go ahead and right-click in there. Oh, sorry, my mistake. Yeah, sheet margin is still 2 inches. So again, some of these carry over from the last time I used this. So you got to watch for that, but that's fine. Under parts, since I need those guys to stay together, they are operational clusters. Okay, and that's key. If I bring those in just from the file itself, just to kind of show you what happens when I do that, if I bring them in just from the file, they don't stay stuck together, and that's not going to work, right? It'll bring in the three tool paths, but it treats them as three completely separate things. And if I was to nest those out, they would just be kind of wherever they happen to be. So we can't do that. They gotta stay clustered together. So we're gonna add these as a cluster. And when I grab those in, we now get one part with all three of those tool paths sort of applied to it. Okay. Now we're gonna go ahead and ask for a minimum quantity of 30, just for fun. I think that should be good. Part to part distance, I'm going to bump that up to say 1 inch. I think that should cover everything. Again, we're just kind of throwing some stuff out there. Grain direction, we're going to go ahead and list that as horizontal, just so I get sort of the consistent sort of direction for them. And then I'm just going to go ahead and take a look and see kind of what Mastercam comes up with. And there we go. There's a whole bunch of sort of those sheets. Sorry, a whole bunch of those manifold flanges. 30 of them, and obviously I can, I think I get quite a few out of them. We'll stick with 30 just so we don't drive ourselves crazy. I'm going to say okay, and that's going to sort of come up with my nested operation there. Now, is it doing sort of every part together? Is it doing sort of, by tool path? What is it doing? So if I back plot that, just out of curiosity, and I'm going to turn off those node points because they're a little hard to see. And I'm also going to turn off I'm going to put it back in what they call incremental or run mode, just so, again, it's a little easier to kind of see where it's going. What are we doing? So you can see it looks like we're drilling the 4 holes first. Okay, so now we're doing the outside profile. So that's not going to work because we're not going to leave those pockets for last. So it's doing them in kind of whatever order it kind of made up its own mind. Okay, so that's not going to work for us. So where do I control order? Well, in the nesting itself, under parameters, we just never got to that. I wanted to go ahead and do it in the Toolpaths Manager order. Pockets, holes, contour. Okay? So the order in which they were originally created. And that should then do them pockets, holes, And there we go. There's pockets. So we'll do the pockets really quick. And we should then do the holes and then the contour. Okay. So you just kind of have to know where those guys are hiding to find that. Okay? Now, I'm going to go ahead and even though, again, this is a ridiculously sized piece of material, I'm not sure how you'd even get that on the table. I'm going to go do a quick verify on it just for fun. Just so we have the little satisfaction of seeing it actually run. But I think we're good. Again, sometimes we do funny things with scale. And again, I think that's 0.375 with the thickness. So that's okay. Sometimes you do abstract and big things just to get an idea of how something can work. Okay, and I'm going to save that. I'm going to call that nest test again. And I'm just going to overwrite whatever my old one was. Probably the same thing. And we'll go ahead and grab our nesting routine. And we'll go ahead and look at that and verify. Now, graphically, sometimes very large sheets can look a little funny once you zoom up, but we'll just kind of go ahead and run those through real quick. And I'll just kind of see if I can get this going as quick as I can. So there's our pockets. There's our holes, and then there was our contour right up there at the end. If I kind of zoom in, we can see our tabs. Again, my graphics card yelling at me about this. There we can see our little 20,000 tabs right where we left them. Perfect. Good stuff. All right. Now, again, exaggerating the size of this material, if I've got a much smaller piece of material, again, we're doing that for fun. If I've got a much smaller piece of material, or, a long sheet, and I'm just trying to get as many as these out of that as I can, again, Transform sometimes asks you to do a lot of the math on your own. And what I like about using the nesting functionality, again, is that it's you can evolve it if that makes sense. I'm never married to anything. I can always go back and adjust things. I can change the quantity. I can change the layout. I can adjust the size of the sheet depending on what I'm being asked to make that day. But the important thing is the parts programmed, or the parts are programmed, and they're just waiting for me to determine quantity. So, once I've got something programmed apart, and I know it's something that I might have to make again in the future, as long as I can find that file, I can nest it as a cluster, nest it as a cluster. I think that's what I said, nest it as a cluster, or nest it individually and basically just control my quantity and determine what my yield needs to be for that day. Really kind of a nice, interesting way to program. Definitely worth looking into. Definitely worth just kind of experimenting with. Maybe it'll work for kind of what you guys do. Either way, thanks for spending some time with us this afternoon. I hope you picked up some good tips, some good tricks, and I look forward to speaking to you guys again. So thank you so very much.